Hello, everybody, and welcome. I'm Valentina Izzo, Marketing Content Manager at WordLift, and today I'm with Max Geraci, SEO expert. We will talk about semantic publishing and entities gap analysis and how to use the application Max developed that is called Entities Swiss Knife and WordLift together. If you have any question, you can write in the chat. And I will start. Max, welcome, first of all, and thank you for your time. And so please introduce yourself and start the presentation.
Thank you. So, hello, my name is Max Geraci. I'm the co-founder of Makoto Studio, a little agency my name in Bologna and Northern Italy, and specializing in content marketing and SEO. I've been doing academic research for at least 10 years in the sociology of technology field. So my usual tools of research were semiotics, knowledge representation, computational linguistics, and these tools came in very handy in the last few years in my daily job as an SEO, since the use of natural language processing had become to be easily applied to the online search. As a result, the so-called entity-based SEO has become increasingly relevant. This passion gave me the opportunity during the pandemic, thanks to the pandemic, even it sounds a bit strange to say, but it gave me the opportunity to study Python. I started to use it just for scraping purposes, but now I use for SEO tasks automation and above all with machine learning and linguistic models. So we'll see an application I've developed, as Valentina just told. So today I'm going to talk about entity SEO, knowledge graphs, and how to create one knowledge graph for your site through structured data. Let's start with the slides. Entity SEO is an advanced approach to SEO concerning on-page optimization and even structuring the site, so taxonomies and internal linking. Following the semantic evolution of search engines, from lexical to semantic search engines, entity SEO starts to consider not the keywords, which are strings of characters, but entities that constitute the page topic. The article introducing the knowledge graph Things Not Strings, which was published by Google in its official blog in 2012, is the watershed marking the birth of entity SEO. The strings in the title are sequences of characters, as I told, and we call them keywords in SEO. To understand and maybe also try to simplify, what we call things is more or less a synonym for entity. In general, entities are concepts or objects that can be uniquely identified. And they can be brands or places, people, things, or more general and abstract concept. So for now, let's simply say that the knowledge graph is made of entities and their relationships. But we'll come back to this definition, to a more formalized one. It is easier to understand what an entity is by referring to topics. The term topics is what Google prefers to use in its communication to a broader audience, whereas in the patents or other more technical documents, they prefer to use the term entity. To try to understand better what a knowledge graph is, we have to introduce two concepts, ontology and knowledge base, because they are really interconnected. They have a close relationship with the concept of knowledge graph. These are often overlapping and confusing concepts. And we have to say that they are confusing even in the academic research and the enterprise, the business-related literature, and consequently their dissemination. So I think that it can be really useful to try to agree upon some simple definitions, so we can better understand what a knowledge graph is and what it means to create a site-wide knowledge graph. So one of the many definitions available, between all the many definitions available, I have chosen to present the simplest one and to offer two different definitions. One is more formalized and the other one is more operative and business oriented. I suggest some resources to go deep in these subjects. For sure, the Ontotext and WordLift blogs are one of the best sources for this kind of information, but also some academic text and researches. So let's start with the concept of an ontology. Ontologies are data models. They are semantic data models that define the types of things that exist in a knowledge domain and the properties that can be used to describe them. So ontologies are generalized data models, meaning that they only model general types of things that share certain properties, but don't include information about specific individuals in our domain. There are three main components of an ontology: the classes, so the distinct types of thing that exist in the data in our knowledge domain, the relationships, which are specific properties that connect classes, and the attributes, the properties that describes the individual class. So as you can see, this resembles what we have in structured data. If we refer to schema.org vocabulary, we can say that, in fact, it is an ontology. What is the relationship between an ontology and a knowledge graph? Ontologies are the general data models that serve to create a formal representation of entities in a knowledge graph. So they constitute its backbone. A knowledge graph is created when we apply an ontology, the generalized data model, to a set of individual data points. So a knowledge graph is an instance or a sort of instantiation of an ontology. In other words, we can say that ontology plus data stored in a knowledge base, plus a graph visualization, a graph database, equals a knowledge graph. Let us come to the concept of knowledge base. So what is a knowledge base? The phrase knowledge base was popularized in the 70s in the context of the rule-based expert systems. In their seminal book about artificial intelligence, Norvig and Russell define a knowledge base as a set of sentences or facts expressed in propositional logic. Propositional logic is a part of logic that relies on the opportunity to derive new knowledge from the previous contained knowledge in our sentences. So this is the very crucial point for the knowledge bases and the knowledge graph themselves, as we will see. The point is that we can use inference techniques called knowledge reasoning to derive new knowledge from the knowledge base itself. So we can view a knowledge graph as a graph database. We call it even a RDF triple store, will be back on this soon, which visualize a knowledge base. So a knowledge graph is a graph-structured knowledge base. What's RDF? RDF is the Resource Description Framework. It's a standard proposed by VU 3C and describing how to exchange, reuse structured data to enable semantic interoperability among different applications that share information on the web. Each triple consists of 3 parts. One part is the node, which represents the subject. The edge, or arch, is also called this way, is the predicate that goes from the subject to the second node, which is the object. So we can refer to a triple or represent it like subject to predicate to object. But there are also other ways to look at this definition. So we can tell entity, attribute, value is another way to define a triple. If we think to triples that we use in structured data, their form is this one, entity, attribute, and its value. Or even entity, relation, entity. This last one emphasizes the interconnection between entities and how each can be part of the description of other entities as its attribute, thus forming a very dense semantic network. So here we have our new definition of knowledge graph. That is, I find this straightforward and formalized at the same time. A knowledge graph is a visual representation, a graph database, of an instantiation of an ontology. So it's a graph representation made by nodes and edges and organized into triples following the RDF standard. Nodes are entities and edges are the relationships between the entities. Just as with knowledge base, even in the knowledge graphs, we have the same problem and task of inference or knowledge reasoning to derive new knowledge. And this task is called graph completion. Graph completion, what is graph completion? Well, knowledge graphs, nowadays knowledge graphs are fueled by machine learning, and they use knowledge, natural language processing and NLP to construct a comprehensive view of nodes and edges through semantic enrichment. Knowledge graphs completion is the inferring new edges, the inference of new edges, entities, things, facts, based on the already existing relational data. Graph completion is divided in some other subtasks like entity prediction, relationship prediction, triple classification. Google has filed several patents, many of them commented by the late Wieslowski, on how a knowledge graph, a modern knowledge graph, or the Google knowledge graph can update itself through the collection of new data on the internet and the use of what they call in a patent a reasoning engine. This reasoning engine is exactly what we have called knowledge reasoning or inference technique. But on a knowledge graph like the Google one, these inference techniques are fueled by machine learning. In terms of enterprise knowledge graphs, we have a very important reference, which is yes, this one. We have an important paper called Industry Scale Knowledge Graphs, Lessons and Challenges. And this paper is participated by big enterprises, which are leaders in the knowledge graph projects, like eBay, Amazon, Facebook, IBM, Google itself, Microsoft. And so this definition in some way represents a sort of agreement, a sort of consensus among a more operational definition. There, the knowledge graph is defined as a description of description and storage of objects of interest and their connections. And knowledge graph provides like the layer of shared knowledge within an organization, allowing documents, products, applications to use the same ontology, the same vocabulary, and reuse definitions and descriptions that other creates. Yes. Knowledge graphs, represented in standardized and interoperable RDF triples, provide a great framework for data integration, unification, linking, and reuse. So the purpose for creating a knowledge graph for our site is exactly this: to have the opportunity to integrate data, to unify them, interlink, and also reuse. A knowledge graph is, in this sense, a real asset for our companies or sites, through which the information conveyed by one of our sites is immediately accessible to search engines, including the internal search engines, and also intelligent agents. The accent on the intelligent agents was put by Sir Tim Berners-Lee in his first definition of the semantic web. It was abandoned in more recent years, but now that we have machine learning based application like conversational agents or suggesting engines for related content in a blog or for a product feed in an e-commerce, this concept of being immediately readable, not only for search engines, but even for intelligence agents, has really started to be a real thing. So again, the main benefits of creating a knowledge graph for your site is the improved findability, both externally and internally. Also the opportunity to have a new opportunity to cluster or group and reuse the contents. For example, the WordLift plugin has some widgets that is possible to use to relate contents and to suggest other contents to user relying on their semantic closeness. So improve findability, greater content grouping, and improved SEO in general, because we have a lot of tests, some of them made by WordLift itself, but not only, tests that convalidate the idea that using structured data and structuring a site like knowledge graph improve SEO. For sure, it improves the CTR, because as you know, we can win some spatial spaces on the SERP called rich results. Now we should be clear about what entities and knowledge graphs are and the enormous benefits of generating one for one site. We can describe and see in practice the activities that will allow us to do so, to create and publish a knowledge graph. I'm referring to structured data implementation and the activity called semantic publishing. Semantic publishing is the activity of publishing a page on the internet by adding a semantic layer, or we can tell that it's an activity of semantic enrichment. Semantic layer is a layer constituted by structured data that are immediately readable by machines. So it helps search engines, but also voice assistants and other intelligence agents, as I told, to understand the page meaning, the context, the structure, the relation with other entities, both internal or external to the site, and making so information retrieval and data integration much more efficient. Semantic publishing relies on adopting structured data and linking the entities covered in our document or present in our document to the same entities in various public databases. We'll see practically how to do this. What are structured data? I'm sure that you know, but just to repeat in brief, which are some of the advantages of adopting structured data. Structured data is metadata added to the HTML code, and they make explicit and understandable to the machines the structure of the page, its various components, or we can say the discrete units of content present on the page. For example, video or a list item, a list of articles, a feed of products, or even an accordion with FAQs. We can call each of these content present on the page a discrete unit of content, and we can map these discrete units of content to our structured data. This activity is called topic content modeling. But structured data even allows to make explicit the relationships among these various discrete units of page and to assign them a different order or of importance, and also just show to Google and other search engines the relations between these pieces of content, units of content on our page. And structured data also show the topic covered, or the topic and its subtopics, or the entities that contribute to define, to unfold a topic. Structured data can be expressed with different vocabularies, but the standard is the vocabulary, the ontology created by schema.org, a consortium of made of search engines, the biggest one, that created these widely used standard. Yes, as I told, the mapping of the discrete units of contents, let's think them as blocks, is called content modeling, and can be usefully carried out during the define phase. Nowadays, we tend in the design field, there is a strong tendency to use blocks for design, and these blocks can constitute, these design blocks can constitute the discrete content unit that we have, so we can model our content on them. The content model, thus defined, can be related to a map of topics that we cover or that we will cover on our website. And this activity is called topic modeling, and it's useful to understand which topics are still covered or not on our site. And the structured data help to make these topics, subtopics, entity explicit to the search engines. Entity linking, as I've told, is the process of linking, identifying entities on a document, and then connecting them, linking them to entities present in a knowledge base, in a public knowledge base. This entity linking activity on entity annotation is called wikification, when the entities in the document are mapped to entities present in the Wikimedia Foundation resources like Wikipedia or Wikidata. The schema vocabulary properties used for semantic publishing, and that creates a bridge between structured data and entity SEO, are the about, dimensions, and the same as properties. These properties are powerful, but they are also underutilized by SEOs, and it's partly because the structured data management plugins, except we really have some exception. WordLift is the best one in my personal opinion. But generally, plugins like Yoast or RankMath, they automate the structured data creation, but they don't allow so much customization. And what we particularly need, the about, dimension, and the CMS property to express the entities in our structured data. We also have an important, I'll show this, an important property called the ID, but we'll talk about it during the practical presentation. So that's it for the introduction. I stop the presentation and I just go to my application and then to some. Let's start with a site. This is a web page from a client, and I show this just to cite another important property, because I see that a typical mistake that people make is to publish only a few schemas, especially when they author the structured data manually, and they publish them as separated schemas, so as islands, without interconnecting them. If we analyze the structured data on these page, just with the official validator, we can see, first of all, that the schema, let's do not consider the body, it's really articulated and long. But if we look at its visual representation, here I'm using a free tool called classyschema.org. It's very useful to see these interconnections between our different schemas. So as you can see, the schemas are not separated as islands, but they form the shape, a dense semantic network, which tell a complex story to the search engine. So, for example, we have a medical web page, because the site is about kids' health. And so I use the medical web page property that I used to say the truth, two different type, medical web page and even article, because medical web page, and this is called double type schema or multiple type schema. And it's useful because it allows to use properties from both of the used schema. So our medical web page schema has a property called reviewed by, which is not present for the article. it is very important to establish the EIT of the site, because every single article is both written by real physicians and reviewed by very important physicians. So it's a signal that I want to be immediately available to Google. Let's consider that this site, even it was written by a physician, was hit very hard by the very first knowledge update. And it was after a few months that I've integrated structured data through WordLift in this case, but I'll show the integration because it's an interesting one. I'll show it later. When after a few months of the publication of this kind of structured data, the traffic came back at the next update, and now it's more or less at the same levels as before the first medical update. In this representation, as you see, we have the nodes, which are the schema properties, for example, the FIQ schema, and the node, the edges are the properties. So an FIQ page, this is the node, is part of, this is the property of the medical web page. The medical web page, sorry, this is another node. So we have a triple here. As you can see, these pages, these schema types are interconnected by using their ID. The ID is the unique machine identifier of the node, and we can use it to create schemas as snippets or bricks to create such big and complex representation. I've introduced these because my application relies on the IDs in order to merge your actual structured data to the ones generated by the application. So let's go with this. I just share it. I try to reload it, but yes, it's working. But I have a local installation too to show it. Just 1 second of patience. This application is part of a project I'm realizing with Israel Godet, who is a smart Canadian marketer. And it's a Python application with a simple Streamlit interface. Streamlit became very popular amongst the SEOs who use Python to create application for automatize for SEO tasks automation, or even for machine learning and natural language processing applications. And Streamlit provides, it's a library, a Python library, which provides a very simple user interface, a very simple way to generate a user interface. So let's do some live examples. We take not this one, we take this URL. And as you can see, we have two different options here, the URL analysis or the SERP analysis and the entity gap analysis. Let's start with the URL. We can check entities from a single URL or for a provided text if we have written an article but we haven't published it yet, or URL versus URL. Let's start with the simplest one. I copy paste the URL and also select to extract all the IDs from the schema that is still present on your web page. And I can also decide if I want to extract only the entities present on the tag title or in the meta description, or even the entities present in all the H's, H1, the headlines of the text, but I'll go just with the ID. Maybe I prefer to run it locally. It's simplest. And so let's use the same URL, and I can extract, as I told, the ID, and I go with the entities extraction. It takes just few seconds because there are, but maybe it finished here. I can also extract categories and topics. Sorry for me going back and forth, but this is a beta. If you want to reach it, the application, its URL is entitieschecker.com, but as you can see, I'm still fixing some slight issues. So I submit, I extract the ID using a Python library called extract, and then I extract the topics and categories too. I just see which is the fastest. We have to just wait a few seconds here, because in this version we are also scraping all the entities descriptions from Wikipedia, which can be very useful when we inject them in our structured data. So the submit button is not working here. You have to have just a few seconds of patience. So we'll see the best way to take this portion of code created by the application and directly inject it in our current structured data. So it's quite finished. And then we can select the type of properties that we want to inject the entities into. As I've told you, the main properties for entity injection and entity annotation are the about and the mention property. Let's say something about how to correctly use these about and mention properties. The about should refer to one or two entities at most, because it represents the main topic of your page, and it should be also present in the H1 title. So if we optimize our article doing SEO, entity-based SEO optimization, we have to use this about property for just one or two entities. Dimensions properties should be no more than 3 to 5, depending on the article's length. Generally, an entity or a subtopic, because we have seen that an entity can be considered like all the subtopics that together contribute to unfold our main topic. So dimensions properties should be 3 to 5, and they should be, this is an important point, explicitly mentioned in the markup if and only if a paragraph or a sufficiently significant portion of the document is devoted to that entity, or just for disambiguation purposes. So we have, as we can see, many entities on a page, many entities of page on a page, but we have to inject just 3 to 5 in our mention property, and that they are the most prominent one, or we can look at here the most salient one, the one which has the biggest salient score. So we can check our entities. They are ordered by salience. So for sure, the first one is our is the one to be injected in our about property, and we also can choose some entities for the mentions properties. When we choose them, this button appears to download the entities, and if we open it, we have this snippet of code. The important part here is that we have extracted all the IDs present on your page, and we have to choose the proper one, the proper schema type, where we want to inject our entities. So in our case, it's the article, or it can be the medical web page, but sure it's not the person or the parent audience. As you can see, I like to create very specific and little schemas and then connect them through their IDs. So I choose article and I download the entity, and the ID is correctly the one that we should use to inject it in the proper way. For the entity injection, we just use, I'll show you a backend, the backend of one of my personal sites. Let's see, just agency site, because it has a simple plugin to just copy paste your code from here, let's say this one, and you can just inject these through this plugin, and the plugin will be available for free from the application site, and it's a simple code injector. It injects snippets codes in the header, and that's it. So paste the JSON generated by the entities with knife. We put here the code. As you can see, it creates structured data following this format. This is the about property. This is injected in the schema with this ID, which is the article schema, and it has a name, which is the name of the entity, and it's a type, and we also has the description and the linking to Wikidata and Wikipedia. I use these application to inject entities, and the advantage is that it allows to do so even for very small sites when we cannot go to bigger applications or more complex applications like WordLift itself is. I show you the backend of this article. As I've told you, I'm using WordLift on this site, and I also want to show an important specific feature that WordLift has and that is not present in the application. We go to the WordLift plugin. WordLift essentially does the same thing of annotating entities and injecting them in the structured data. The interface is immediate because it immediately extracts the entities from your text. I mean, it does it live in real time, and you can choose the one you want to inject in structured data. But sometimes it happens that the about property is not exactly what I want, or maybe it extracts one property for the about property, just one entity, and I prefer to have two of them, and so I use my application to inject the other entity. But the very cool thing here is that part of WordLift, which has another same as property, as we've seen, the same as is a connection property, but this same as is not a same as the same as that we use in schema markup. This is an old property, and this is to interconnect our entities, our page, to publish our personal entities in the LOD. It's the linked open data cloud, and it's an enormous network of public databases where the contents, the entities, the knowledge is published following the so-called 5 stars standard created by Berners-Lee. One of the characteristics is the possibility to identify each entity through a unique identifier. It's the URI or the URL, but the URI is without the protocol, the exchange protocol, and WordLift as these unique. I really think that it's unique on the market possibility to create your own entities and to publish them on the linked open data cloud. So the last thing I want to show you, as I told you, extracting entities from a text is quite the same that from URL. It's when you don't have a published text, so you have to simply copy paste it here, or you can do an URL versus URL. So for example, let's take these. Let's take this URL here. And let's also take a second URL. Again, it should be, it is a long operation because it has to extract from 2 URLs. So sorry, because I'm running it locally and I don't want to waste your time for this. But it simply compares the 2 URLs and show on a table which are the unique entities in your URL and the unique entities in, for example, your main competitor, so you can see if you have to use some other URL, some other entities on your pages. But let's go to the SERP analysis. This is the other important feature that I want to show you. I've recently seen that it's also possible to do this with the WordLift add-on for Google Sheet, but the add-on uses the WordLift, your personal WordLift keywords. So you can use these as an alternative, and they also have different purposes and way of visualizing the results. So let's just search for a query, semantic SEO, and we do our search in the United States and in English. And sorry. Yes, I have to search these other. Yes, because in the final version of the application we rely on different APIs, so we are just checking which are the performances of some of them. This is mainly a test ambient for now. So this is the SERP in real time. We scraped it with scraping API. So we have the first 20 results. We can, WordLift is here. We can choose, let's say, five results. And then we have to change, we have to choose this number, and this is the number of the minimum pages that have to share an entity. So, for example, I want to see all the entities shared by at least 3 of the pages present here. I extract them, and I immediately can see only the shared entities by 3 pages. And if you increase this number, you only see the more important entities, because we consider that they are present on every single page. Or we can just go and see what is present on all the SERP. So we can select 10 results and say to show all the entities present on the SERP. Well, I stop now, so maybe there is yes, it's a bit long. We can have space for questions if you want.
Okay, thank you, Max. We have a question. Michele asks, do you recommend using entities as anchor for internal links?
Yes. This is a very interesting question, and me and other guys in some groups are doing tests on this subject, on using entities as our internal link anchors. From what I've seen till now, I absolutely recommend to do this, but you can use even sorts of variation. So you can include your entity in the anchor, but also using its surrounding text as a part of the anchor to create a differentiation between your anchor's profile. But for sure, the structuring of the site, trying to follow the same kind of structure that we have in our knowledge base and in our knowledge representation, so in our knowledge graph, is for sure, for what I've seen till now, a way to improve our internal links. I'm doing a lot of tests of normal keyword-based anchors against versus the entities-based anchors, and I'm going with the entities right now. So yes, it can be a proper way to do your internal linking.
Okay, and I have also a question. So I saw that in the application you show us before, there was a property called knows about.
Yes, the knows about. Yes. So as we have seen, we use the I can put an URL here. Yes, but we can use the about and mentions properties to define the topic and the subtopics covered on our document, on our web page. Our article. I'm not referring to the article type. The knows about property is another one that we immediately can connect to external knowledge bases, and it's used to define what a person, or maybe we can use it even for organizations, local businesses. So what a person or an organization knows. No, this is for me, for example, on my web profile, I can inject the knows about. I can use the knows about property to inject some specific entities like SEO, because I effectively know about SEO or digital marketing or content marketing. And you can do the same thing with an organization. We can say that an organization knows about, think it as is specialized on some specific activities or fields. So the knows about properties, another one, it's less used obviously than mentions and about, but it's very useful on the writers or persons in general profiles, or the about page of an organization and so on. Yes. Maybe I can stop sharing my screen.
So we have another question from Alessandro.
Yes.
How do you select
focus?
How do you select anchor text based on entities? What's the procedure or the logic you follow?
Yes. Okay. As I've told you, I first of all extract all the entities from a page. And when I do the topic modeling part of my site, so when I analyze or create the topical map before starting to create the site itself, it is a procedure that we can do even if the site is still live. Once I create a topical map and I see how the different topics are clusterized, what is their semantic closeness, I also can see if they are still interlinked or not. The topical map allows me to see if some articles are close to each other on the semantic point of view. If I don't have an internal link between these two pages, then I choose to interlink them. And in that case, I look at the entities of the page that has to link the other ones of the source page, and I choose an entity which is which has a big salience for the page, because I want to interlink the main topics or subtopics. So again, the same entities that I've chosen for the about and mentions properties can be the one used to form the anchor as a partial match, or just creating a contextual sentence to create a more surrounding meaning context that Google or the other search engines can understand.
Okay.
So they are essentially the main entities of the page that I use as anchors, as internal link anchors.
Okay, so we have another question from Antonio, and he said, I see that in the latest version of the app, there is an internal linking entry. I have read a couple of articles recently. Could I ask you, what is your approach?
Yes. I will not show it here because for now it's in beta, and it's relying on an EV machine learning model, linguistic model, and so it's a bit slow. But we have many different approaches. I won't tell what I am exactly using now, but I can present some of the approaches that we can use for qualifying pages to interlink them. First of all, the first qualification is based on crawling the data. So we can divide the pages into main buckets, and they are the strong and the weak pages, or the pages that has an internal page rank which is high or low level. And this is the first qualification. But when we choose to empower a weak page, we need a suggestion of the best candidates from the strong pages bucket. to determine which are the more semantically close pages, the more related pages, we can use language models. For example, BERT itself, just because it's an open source model, so it's free. You can use it, but you could use even paid models like GPT-3. But you can use BERT to do a task called semantic similarity check. And it checks the similarity between the pages, maybe just looking at their title and meta description. And from these check, you know which are the more semantically related pages. Or you can also use the entities profile. You can extract your entities and just choose to use the first 5, 10, whatever, and do a semantic check between the two profiles. Or we can use an entity profile from a page and match the entities against the ranked queries that we retrieve from Search Console. Or we can again import the ranked keyword from a paid tool like SEMrush or Ahrefs, and then try to match that keyword to the text, to the whole text, the body of the article. So we have different techniques. The easiest one, maybe, not considering the string matching, that it's quite not reliable at all, even if most of many, or I'd say all the commercial tools that I've seen using a simple string matching, we can at least use a fuzzy matching, a more advanced kind of matching, which consider the plural, singular, so that clean the text a bit and consider some synonyms. And in this way, we have a more precise suggestion. We can use semantic, we can use fuzzy matching even in Excel or Google Sheet. So if you do this manually, you can extract your ranked keywords from a source page and then from a target page and try to fuzzy match the keywords against the other keywords or against the title or the headlines in your article. So this is the different approaches that we have. I'm choosing to try an approach based on machine learning and a big linguistic model, even if it only relies on GPUs. So try it at home only if you have a fast GPU.
And are you there is something else that you are developing to with Python or with the language models to?
Yes, something, maybe there is something, just another thing that I can show, sharing my screen. Is the screen shared, right?
Yep.
Okay, we have these link relevance tool. This is an interesting thing I'm taken into consideration recently, thanks to a very smart SEO called Bradley Benner. He specialized in local SEO, and he has a link building agency service, and he has shared a lot of tests regarding the topicality of a backlink or of maybe a site where you want to host your guest post. So we tend to consider that only the page where we post our content should be relevant to the content of our linked page or site. But a lot of tests clearly demonstrate that the topic the topical category of the domain where you publish your guest post, or the domain which is linking to, or from which you are buying links, because, well, everyone buy links. And if the domain is not aligned, if its topical categories is not aligned to your topical category, the link, the backlink, is less effective, but in an order of magnitude. So one thing that we can do using the Google Natural Language Processing API is to use a function called classitext to classify the text, so to obtain the main category of a domain. And so we can put our domain here, and the list of our backlinks or of the domains proposed by a seller, or from the domains we collected for our guest posting campaign. And we can check if that pages and also the domains are on topic versus our personal domain. I shared the screen to show an example, but I should open Href or some other tool to extract a backlink list. But this is exactly the way it works. Google provides 1, 2, 3 categories per page and per domain, and we can do a simple match between the categories of the target page and the categories of the target domain versus our category, the category of our domain. So I think that these Bradley, I think that calls these topical trust flow, and it means that your trust flow is a famous metric used by a third-party tool. It's Majestic, so I think you are all familiar with it. All SEOs are familiar, especially the ones working on link building. But Majestic uses its own classification algorithm. So I think that, and we are having great results in picking up the right sites where to publish our guest posts, is to use Google API to immediately see how Google sees the topical category of the page, and to have them as closer as possible. Yes, I think that this is quite an interesting feature, and I hope that people will be happy with this. Again, I repeated the domain, but go from tomorrow, because I have to fix, as you have seen, many things. But the domain is entitieschecker.com. It's free for using the entity gap analysis, because you can select the entities shared by search results and also confront them with your page to have the gap, so you can know which are the missing entities on your page, on the entities uniquely present on your page. This feature is free too, but you just have to subscribe for it. Just subscription, because some application has some bot visiting them and it continues to crash. So I prefer to use a sort of identification just to avoid bot traffic, but it's free.
Thank you so much, Max, for your time for this webinar, and thank you everybody to stay with us. I say have a good night, a good day, and see you next time. So thank you, Max.
Thank you, Valentina. Thank you, all the guys from WordLift. I have to disclose myself. I have a personal passion. I fell in love with WordLift years ago, so I can consider myself an ambassador, I think.
Oh, thank you.
Because, but it was particularly inspiring, the concept and even some of the codes that Andrea Cyberendi, the CEO from WordLift, shared. I studied them during the pandemic and started to think how to start from them to implementing my personal thing. So thank you for inviting me. To be one of your guests is particularly happy for me. It's an honor for me to be here. So,
thank you. Thank you. See you next time. Bye.
Bye.